All right, so for the first one, 5p cubed minus 4p squared plus 7p minus 56. You should have gotten 5p squared plus 7, p minus 8. Number 2, 5a squared plus 7, 6a plus 5. Number 3, 4 was your common factor, and then you have 7b squared plus 3, 8b plus 1. 8 was your common factor, 7n squared minus 6, 5n plus 6. These did not have common factors. 3m plus 2, 5n plus 6. They did have multivariables. A squared minus 4b, c plus 5d. Just the basics here. You're going to group the first two, group the last two, and then you're going to look at those individually and see what they have in common. For the first group here, between 5 and 40, what do they have in common?
5.
And between p cubed and p squared, what do they have in common? P squared. So we're going to say 5p squared comes out of that first group. 5 divided by 5 was 1. We had 3 p's. We took out 2. So 1 p is left over there. 40 divided by 5 is 8. P squared, we took all of them out. So that is my group. We look at the next group. Between the 7 and the 56, what can come out? 7. What about any variables? Can any variables come out? Why not? 56 does not have a variable to give me. All right. 7 divided by 7 is 1. And then we have that p that we did not take out. So just 1p. 56 divided by 7 is 8. Now at this point, you should see that we have a little theme going on. They both have p minus 8. So we're going to take out that p minus 8. And then what is left over is 5p squared plus 7. And that is my answer. All right, so I will say this was a big one. It had big old numbers. I wouldn't give you quite that big of numbers. If you started with something like 2 and you can see they're all even, you would just keep taking 2's out until you got to 8. There's 3 times that a 2 can come out of here. So if you take a 2 out and you're like, they're all still even, I can take another one out. Oh, I can take another one out. You'll see that your common factor here was actually 8 between all 4 of these. 2. So you're looking for a common factor. They're all even, so you can see 2 would come out, but that's not your biggest one. If you took a 2 out, I think actually 8 comes out of everything, if I'm not mistaken, right? The common factor first being what you're looking at here. This one was a big one, so we're going to take an 8 out before we ever start. Before we ever start grouping, we're going to take an 8 out, all right? It comes out of absolutely everything. And so when I do that, I would do that with variables too. If there was an in every single one of them, I would take a variable out as well. So whatever's in common to all 4 of these, you're going to take out first. And then you're just going to look at them. If I put 8 into 280, what do I get? How many times does 8 go into 28? We'll start there. 3 times, right? And then 4 left over, so 8 goes into 45 times, right? Something like that. All right. What about the next one? 8 goes into 33. How many times? 4 with 1 left over. 8 into 16. How many times? 2. And we have that n squared. Yes. All right. 240. That's an easy one. How many times does 8 go into 24? 3 times. So 30 there. And then 288. How many times does 8 go into 28? 3 times, right? With 4 left over. How many times does 8 go into 48? 6 times. So we have our division there. Now we don't have anything in common between all 4 of them, and we can go ahead to our grouping. All right, so we're going to group the first 2. Now if I group the last 2, what do you notice? I grouped behind what? A subtraction. So what do I have to do to the last term? Change the sign, right? It's already a minus, so I need to change that to a plus. All right? Does that make sense? I grouped behind a negative. Now I'm going to look at these individually. I'm going to leave my 8 right there. You'll notice I'm putting brackets so as not to confuse what's going on. All right? And then I am going to decide between the 35 and the 42 what can come out. What comes out of a 35 and a 42?
7.
A 7. What about my variables? N squared. So 35 divided by 7 is what? And then I took 2 of my 3 ends, so I have 1 left over. 42 divided by 7 is 6, right? And I took both of those ends out. Now I'm on to my next group. Between a 30 and a 36, what can come out? 6. I cannot take any variables out because my 36 doesn't have any to give me. All right, 30 divided by 6 gives me a 5. I still have my n. 36 divided by 6 gives me a 6. All right. So far, so good. I still leave this 8 here. Now I can put groups. My common group is the 5n plus 6. What's left over is 7n squared minus 6. And that is my answer here. All right, so for this one, you have a 1, a 5, a 4, and a 20. Nothing can come out of those. You have an A and C, A and D, B and C, B and D. So no variable can come out of all 4, all right? So there's actually no common factor between all 4 terms here. You have to just go straight to grouping, all right? So we're gonna go to grouping. We're gonna group these 2. What have I grouped behind? A subtraction. So what happens to happen to that minus 20? I need to change it to a plus 20, all right? Anytime you group behind a negative, you have to change your last sign. Your last sign. And now we're going to go straight to our common factors. I have an a squared, I have a 1 and a 5, so no numbers can come out here, right? A squared, A squared. I can actually take an A squared out. Here I have a C and a D, so A squared is actually the only thing I can take out of this group, A squared. I'm left with just the C. That's what's left here. And then I have a 5. I took the A squared out, and I have a D. Right? On to my next group. Now between the 4 and the 20, I do have a common factor. What is it? 4. For my variables, I have B and B in common, so I can take a B out. All right. 4 divided by 4 is just 1. B divided by B is just 1. That comes out. I'm left with a C. 20 divided by 4 is 5. I took a B out. I'm left with just D. And then you can see very quickly what my common group is here. My common group is going to be the C plus the 5D. So that's my first group here. And then what I have left over is an A squared minus a 4B. And that is my answer. All right, so when we did trinomials, we always had just a 1 in the very front. Our leading coefficient was a 1, okay? And so we only had to really worry about that last term and how that was affected by multiplication. But I want you to look here at something like this foiling that we have in front of us. Right now we have 3x minus 2 and x plus 5. If we FOIL that, 3x and x gives us 3x squared. So this first term here is created by my first terms, right? 3x and x created 3x squared. Everybody see that? Negative 2 and positive 5. Negative 2 and positive 5. That gave me that negative 10 right here. So my first terms create my first term. My last terms create my last terms. That's pretty straightforward. And so far, we've only had to worry about the last term and how those added up to the middle. But when you have something like this, the middle is created by more than just the last terms. My middle here is 13x. There are no factors of 10 that add up to 13. Why is that happening? Well, because I have a 3 up here. And so all of a sudden, my leading coefficient is affecting my middle terms. My middle terms add up to give me my final middle term. And they are the product of the outer and inner terms, always. Okay? Now that was really simple when my first term was a 1. because the 1 didn't affect anything. 1 times something just leaves it alone, right? But now I have a 3 multiplying. And so I start looking at all my possibilities here that could create the 10 and the 3. Well, the 3 is easy, 1 and 3. But the 10, I have 1 and 10 and 2 and 5 that could possibly work together in a foiling situation. And so then you start doing this mix and match thing that happens. But the method that I actually teach this is I teach creating a 4 term that you factor by grouping, okay? Because if you can figure out what those 2 middle terms are, then you can do this grouping process and it will work for you. But you have to remember that this guy is created by the product of these terms, okay? So you do a sum of the products to get that middle term. All right, so let's look at this example. We have 3x squared plus 7x plus 2. My first term has to be created by my factors of 3x squared, right? We know my first terms. So my first term, this guy right here, has to be a product of my factors of 3. Well, 3 is prime. That was nice of them. We obviously are going to have 1x and 3x to give me 3x squared. Those have to be my first terms. Does everybody agree those have to be my first terms? This is my only option here, okay? My very option for a prime number is just the 1 and the number. So I know that my first terms have to be 1x and 3x. That's the only way to create 3x squared, right? Absolutely the only way to create 3x squared. Now here's the situation I run into. My last terms must be a product that creates 2. Well, 2 is also prime, so that's nice of them, right? My last terms have to be a product of 1 and 2. So you would think I could just say, oh, well, that's 1 and 2. I am done. But does it work? Well, we can FOIL it. 1 times 3x, that's 3x squared. 1x times 2, that's 2x. 1 times 3x, that's 3x. 1 times 2 is 2. I have a little bit of a situation here. When I combine those, what am I going to get? What do I want? We have a problem, right? So now all of a sudden I have to do this matching thing. Like, okay, I need to add up to 7, but doing it this way doesn't. And so you start toggling, which is not bad when it's prime, 2 primes. There's only really 2 ways I could do this. 1 and 2 or 2 and 1, right? And the actual way I'm supposed to do this is 2 and 1, because I'm going to get 6 when I multiply by 3 and 1, which gives me 7. That's nice when it's 3 and 2. When it's something like 20 and 35, or something bigger, which I'm not going to be quite that big, even anything like 12, 1 and 2, 2 and 6, 3 and 4, right? And then what if the other guy is something like 8, 1 and 8, 4 and 2? Then how many groups could I possibly sitting there mixing and matching till I get the right one, right? And so I actually teach a method. Sometimes it's called, I think, like the rainbow method, because you draw across and you just create a 4 term and then factor it. Now you will get to the point, like I could look at this and I would know that I need to pair that 2 up with that 3. All right. What I mean by that is I can look at this guy and I can say, I know for a fact that pairing the 3 up with the 1 when I multiply is not going to work, because I need a bigger number than that. All right. And so when you want it to multiply by something, it actually has to go in the opposite group. So I would actually have to say, okay, here's what's actually happening. Yes, it's going to be 1x and 3x, but I need to add up to 7. So I really need to multiply 3 by 2. Well, that's multiplying my inner terms, which means my 2 needs to go here. That's where 3 is not going to multiply by the group that's what's in his group, right? He adds to that one. So if I want 3 to multiply by 2, it has to go in the other group, which means the 1 goes over here. So I've been factoring long enough that I can visualize that and see it. You'll get to that point, right? But with larger numbers and larger multiples, and you have 5 or 6 to choose from, you could sit there all day and it's a pain. So the way that the method works is you're going to find factors of the first and the last that add up to the middle. Don't worry about writing this down right now. We're going to do it, and then we're going to see how this works. You rewrite the middle term as a sum of the factors. You create a 4-term guy, and then you factor by grouping. All right, so let's look at this same one that we just did, and we're going to use this method. All right, this method right here. What it does is it takes the first and the last, and you multiply them. 3 times 2. All right, 3 times 2. That gives me what? 6. Now I want factors of 6. Again, this last guy determines if they're positive, positive, or negative, negative. Okay. Factors of 6 that have to be the same sign because I have a positive back here. And I want a positive 7. So they're both going to be positive. But factors of 6 that add up to 7. Well, that's simple. What are they? That's 1 and 6. All right. So what I'm going to do now is I'm going to rewrite this whole thing here as 4 terms. I'm going to leave my first term absolutely alone, 3x squared. I'm going to leave my last term alone, plus 2. I'm going to take this middle term, the 7x, and I'm going to rewrite it into 2 terms, 1x and 6x. So I'm going to rewrite it. So I'm going to say plus 1x plus 6x. All right. Does everybody agree that that will be 3x squared plus 7x plus 2 when it's all said and done? Yes, it will, right? I would have 3x squared plus 7x plus 2. So I didn't do anything that's changing it algebraically. I'm just rewriting it. Now I have 4 terms. How can I factor 4 terms? What method can I use to factor 4 terms? I'm going to group, and I'm going to say, okay, group the first, group the last. What can come out of the first group? 1, and then variables, I can take out an x, right? What am I left with? 3x plus, what's x divided by x? 1. Remember, if 1's the only thing, you have to write it, all right? What can come out of the second group? A 2. I'm left with 3x plus 1. And my last step here is to separate my groups. 3x plus 1. And x plus 2. I do not have to mix and match and toggle to see which way I need to write it. I can split it and factor by grouping. All right? Multiply across, that's what this means. A to C, multiply across. You have a new guy here. You're going to look for factors of that one. That will give you your middle term. Rewrite it to 4 terms. Factor by grouping. So your first step here is to multiply across. Then you're going to find factors that add to the middle term. Rewrite to 4 terms. Then factor by grouping. And we're going to do a couple more of these before you do some. So we're going to take the first term and we're going to multiply it across to the last term. 2 times 24 gives us what? 2 times 24. 48. I want factors of 48. This last guy is positive. So I know they're going to be the same sign, right? I know that because it's positive. And which sign are they going to be? They're both going to be negative 19, all right? My middle guy helps me figure that out, all right? So they're both going to be positive. They're both going to be negative in order to give me a positive, all right? And it means I'm going to add them up. So I want factors of 48 that add up to give me 19. What factors of 48 add up to give me 19? There's lots of factors of 48. 12 and 4 give me 16. So I do know I need to get a little bit bigger than that. Yep, 3 and 16. 3 and 16. Add up to give me to 19, right? They're both negative, yes? -3 and -16 will multiply to give me that positive 48. They will add to give me the 19. So now I'm going to rewrite this guy. I'm going to leave the 2x squared exactly the same. I'm going to rewrite the -19x as -3x and -16x. Make sure you put your variable in there. All right, 3x and 16x. Then leave the 24 alone. I have 4 terms I'm going to factor by grouping. All right, 4 terms, so I'm going to factor by grouping. So group the first 2. Just like the rule of grouping, I'm grouping behind a negative. What needs to happen to that 24? Change it to negative. All right? What can come out of my first group? Nothing between the 2 and the 3, but what can come out? An x. I'm left with 2x minus 3. What can come out between 16 and 24? Something a little bit bigger. 8. There we go. And I'm left with 2x minus 3. Then I'm going to take this 2x minus 3. And I'm left with x minus 8. You can check it by foiling. You can always check it by foiling. You can do a quick check just with your first and last terms. 2x and x give you 2x squared. -3, -8 give you positive 24, right? And then 2 and -8, -16, -3, -19. Your outer and inner should give you your middle term, all right? So everybody see what we're doing. Multiply across. You have a new number. Look for those factors that give you the middle term. Rewrite it as 4. Factor by grouping.